what's going on in the brain then, Margaret Ann?
Good question. I'm not in any way medically qualified, so this is just what I've picked up over the years. But everybody's brain is different because it's plastic. That doesn't mean it's made of plastic, but because it changes and moves. All the things that have happened to us during our lives, the influences, the events, will all have affected our brain and how it actually is. And so it's unique. It's like a fingerprint. So you can have identical damage in two different people, and the two people behave completely differently.
Because of their experiences.
Because of their experiences, become the sort of person they are. I think I increasingly think after many, many years working in the field, the person's personality, what the doctors said pre-morbid personality, before they got ill, is what we really need to understand. And some people will react, say, to seeing things around them that are not real, are saying, well, actually, I'm not that bothered. I can see something, but I know my wife will look after me. Somebody else might see the same thing, say, oh, I'm going mad. What we want, I think, is a balanced understanding with the complexity of the brain, and acknowledging the fact that our knowledge can only ever be in this context, is very, very simplified, and a holistic approach to dementia care.
So it's going back to that Kitwood flower again, of understanding the identity of that person, the relationships, the environment, a sense of comfort, if they're at peace.
Yes, so we try very hard. It's interesting. I think most of us find it interesting to learn about the brain and think, well, this fat's there, this is there, why, what next is usually the question. Who knows? But everybody is different. There's this old saying, once you've met one person with dementia, you've met one person with dementia. Everybody is unique. And so this balance is what we're after.
The MRI scanner is used to see the soft tissues, the skin, fat, muscle and internal organs, and allows researchers to take detailed pictures in 3 dimensions which show the structure of the brain. Here we see a subject being prepared for an MRI examination, which uses a very strong magnet, the circular or donut-shaped structure, to take pictures of inside the body. If I scan my brain, here is what we see. On these images, you can see my skull stripped away to reveal the living brain inside. The brain is composed of billions of cells which give the brain its ability to control our bodies, thoughts and feelings. These same cells give the brain its shape and structure. When we look down on my brain from above, we see that it is formed from 2 halves or hemispheres. Looking at the brain from the side, each half or hemisphere of the brain is divided into 4 further sections called lobes. Below the main brain structure is a further single lobe called the cerebellum. Each of these lobes is responsible for different aspects of our brain function. The temporal lobe contains parts of the brain responsible for our hearing and processing of sounds, key areas involved in language and speech, and areas of the brain involved in memory. The occipital lobe at the back of the brain receives signals from our eyes and is involved in vision and processing the information from our eyes. The parietal lobe contains parts of the brain which control movement and processes input from our senses and how we perceive the world about us. The frontal lobe is involved in planning and language. The cerebellum is important for helping coordinate movement and balance. If an injury or disease causes damage to a lobe of the brain, then some of the function of that lobe can be lost depending on where the damage or disease occurs. Now, looking inside the brain, here we have stripped away the top of the head and are looking down into the brain. We see 3 main types of features. On the surface of the brain is a thin grey strip between 3 and 10 millimetres in thickness called the grey matter, and sometimes also called the cortex. The cortex contains cells which are involved in the main parts of brain function. Inside the cortex is the white matter, which shows up the brightest on this scan. The white matter contains cells which join together different parts of the cortex to create a dense network. In the centre of the brain are the ventricles. These contain a fluid called the cerebrospinal fluid, or CSF. The CSF is made in the ventricles and bathes the surface of the brain, filling the space between the brain and the skull to keep the brain stable inside the skull. We can also use MRI scans to follow the connections between the different parts of the cortex, which are called the white matter tracts. This scan shows these white matter tracts and reveals the complexity of the internal structure of the brain. The areas of the cortex can be thought of as being wired together into networks by the brain cells within these tracts. If we damage this internal wiring of the brain by disease or injury, then the functions of the brain networks will be affected and may also cause us to lose some aspect of our normal brain function. Let us now look at what happens to the brain as we age by comparing scans in different healthy people at different ages. These MRI scans show 4 people, aged 25 years, 50 years, 60 years and 85 years old. We can see that every brain is slightly different in shape and size. But let us focus on the darkest grey areas in the images which contain the fluid CSF. These are the ventricles and the spaces around the outside of the brain. The spaces, highlighted now in red, are larger in the oldest person, showing that as part of normal ageing, the brain is shrinking. We know that in older people, the ventricles increase in size, and we also lose about 0.5% of the cortex each year.
The human brain has evolved to look for patterns to make sense of the world. And this applies equally to people with dementia. You will see people with dementia trying very hard to make sense of the world, but the data they're using is corrupted, so they get the wrong end of the stick, but they heroically keep on trying to make sense of it. And I saw this a lot when I was doing the research project with Tom Kitwood, where I had to spend the night in care homes, seeing people, studying people around the clock. Over a 24-hour period, I'd spend the night in the home, and then you'd observe these people. And most people, if they got more agitated, would be wandering around this building saying, I can't afford to be here. I haven't got any money. Please take me home. This is a lovely hotel. They're trying to make sense of what is this place? And that people would then respond, the staff would respond by saying, this is your home, dear. But this isn't my home. My home doesn't have rooms like this. It doesn't have all these chairs. It doesn't have all these people. What is it? Oh, it must be a hotel. Well, it's quite logical, isn't it? Yeah. But then we just say, oh, it's the dementia, but without trying to really understand.
So almost like a jigsaw puzzle with some of the pieces missing, trying to form that picture.
Exactly. There are different areas of the brain. There's the modern part and there's the primitive part. Now, there used to be a few years ago a big fashion for talking about the chimp brain. Do you remember?
I do.
That's apparently not acceptable any longer, as far as I can make out. But I'm interested in the work of Dan Siegel, who works with teenagers, not people with dementia at all, but he's got some very readable books on the brain and how it works. And he describes the different levels, the modern and the primitive part. And the primitive brainstem contains the limbic system, which has several organs in it. Hippocampus, which is the memory store, the hypothalamus, the thalamus, and the amygdala, which I want to talk to in a bit more detail. But he also has a very good exercise, which I find is very useful. If I hold up my right hand, I have a model of the brain. this is the primitive part of the brain. My thumb is the limbic system. Push my thumb fingers over, and that's the frontal temporal lobes. And this bit with the nails is the prefrontal cortex. This is the most recently developed, evolutionary-wise, it's the most sophisticated part of the brain. It's the bit which controls our behaviour, among other things, and is really important. So if you, as a carer, are confronted with somebody who has flipped, and like that, the prefrontal cortex is not in control.
Right.
You have got to get your own prefrontal cortex in control before you can help them.
Okay.
It's a bit like, they say in the aeroplane, put the oxygen mask on yourself before you help the person next to you.
Sure.
So here is a picture of the prefrontal cortex. The red area is the prefrontal cortex, the hippocampus shaped like a seahorse, the brown, do you see?
Yes.
That's the store of memories.
Right.
And of course, emotional storage very close to it as well. And then you've got the amygdala, which I'm going to talk about in a bit more detail because it's so important for understanding behaviour. So I'd like to share with you a slide which is actually from Teepa Snow's material, which we know how good she is.
Absolutely.
This is a direct quote from her. The amygdala are incredibly powerful parts of the brain, and that will stay with us until the end. They're there in infancy. You can see them on a scan. It's extraordinary in very tiny children, and they're there in the late stages of dementia. They're designed to keep us alive, safe, and happy. And even with a healthy brain, they can overwhelm us.
Right.
We need to understand that when a person is living with dementia, the neocortex is one of the first pieces to go, which leaves the amygdala in charge. We need to keep both our amygdalae, because there's one on each side of the brain, under control.
Right.
And we don't understand enough about this, but as you were saying earlier, it's like a jigsaw. It's putting it all together.
Yes.
And the amygdalae are really, really crucial in explaining behaviour. And basically, you don't want to get into a situation where the amygdalae warn of danger, they sense a danger, so they act as sentries to alert us to potential danger. And they also guide us how to get our needs and our pleasures met.
Okay.
So when sensing danger, it takes over the inner engine system and sends a rush of chemicals, cortisol and adrenaline, throughout the body, where quick reaction might help us to survive. And it's obviously from the primitive brain, and in a situation in evolution where running away from a wild animal would have saved our lives. It's an extremely useful.
Yes.
The adrenaline is what you need, but it's not so useful in everyday life in the 21st century. It's designed to help us to escape or eliminate or overwhelm that which presents a clear and present danger. So this must be why you get outbursts of real aggression sometimes and violent, difficult behaviours, because it's a response to this.
Yes.
And of course, the adrenaline produces the fight or flight or freeze reaction.
Yes.
And stays in the body for an hour and a half afterwards. Okay. So you can have a situation where a couple are at odds. The wife maybe is trying to shower her husband and he won't let her. He's getting more and more and more angry. They have a real tussle. In the end, she manages somehow to manhandle him out of the shower without really having succeeded. Gets him downstairs. Her heart is beating. His heart is beating. She goes and makes herself a cup of coffee, goes into the other room, calms herself down. But these chemicals stay in his brain and his body, and he doesn't realise what it is that's upset him. So he'll have forgotten because of his short-term memory. He'll have forgotten what the row was about. All he knows is he's terrified.
Right. So a
And
catastrophic.
It's a catastrophic reaction, and we really, really need to try and avoid this if we possibly can. And we do that by putting this jigsaw together, by looking for what the triggers are, the things that we know are likely to cause problems, and eliminating them. And, you know, we've all had, you and I have both come across many examples of things like that. For instance, the Wendy Mitchell's example of the television looking to her like a black hole.
Yes. And that sort of fear.
Total fear.
Yes. Yes.
You know, how you just cannot reason your way out of these situations. So the only thing to do is really try to prevent it. And then just before we finish this session, I'll just have a quick word about the hippocampus, which is located in the limbic system, as I've said, and is the memory store of the brain for short-term memories. And it's the area which where dementia, Alzheimer's starts. So this was done we realised this after several longitudinal studies, people who volunteered to have their brains scanned annually. And they're usually relatives of people who've had dementia. There's a big one at Oxford. The various universities have them. So they get a longitudinal view, and through this they learn that the first bit to go is always, in Alzheimer's, it's always the hippocampus. And we used to use this image of a library. Do you remember?
I do.
A bookcase
yes.
of memories. So that your memories of long ago are right on the bottom shelf. They're safe.
They're intact.
And then as they get up the shelves, they get nearer and nearer to the present. And say the bookcase rocks. The books all fall out. The only ones that are left are the ones on the bottom shelf of long, long ago. And so that's another thing we need to be aware of in the brain is how must it be like to live in a world where you cannot recall your recent memories. And we now know, I used to say years ago that people, we were all told it's a question of retrieval. The information is all there in the brain. It's just that the people with dementia can't get it out. We now know that those recent memories are never laid down.
Right.
They never stick.
Right.
So it's like trying to throw something at the wall and make it stick. It just doesn't stick. So it's no good if you've taken your person to a music group, left them there, you pick them up, you say, what did you do? And they say, I don't know. It's no good going on and on and on asking them because they don't know. That ability to form a recent memory just isn't there.
But it does seem that sometimes the emotional memories remain, and people come away with a sense of, I don't know what happened, but I know it was something good, or I know it was something bad. Yes.
This is very interesting. We would say the facts go, but the feelings remain. And this is absolutely true. It's observable. It's easy to see. So it's really, people will say to me, and have done, oh, there's no point in doing anything with mother because she won't remember. But there's much more to life than memory. If life is made up of individual moments and you can fill those moments with fun and laughter and feeling good about life, isn't that worth it? It's not just, we're not just defined by our memories.
No.
God help us if we are.